Hey everyone, Nick Russo here. In this video, I want to talk about a concept that I semi-pioneered earlier this calendar year about maintaining books as code projects. Now, the idea of maintaining like software documentation as a code project that is something like Sphinx or posting information on Read the Docs, that's been around for a while, and I certainly didn't think of that. But I was thinking about what about just regular books, whether they're technical or not, and they can stand alone as PDFs like the one you're looking at on the screen. The difference is that this wasn't written in Microsoft Word and pushed out as a PDF. I took a different approach and I managed this whole thing as a code project. And I want to walk you through how I do that because it's more than just writing code and more than just version control here. I've actually built a CI/CD pipeline that's continuous integration and continuous delivery. And I've kind of built that using some homemade tooling, and I think you're going to find it really interesting. So again, this document you're looking at was automatically generated and published to my website, and I don't want to spend a whole lot of time on it because it's a long document, but I'm just going to kind of scan through, and you can see, okay, it starts like a book, there's an abstract, you can see that there's some clickable links in there as well. So I give credit to some of my friends who helped me with the book. I have some legal notices. As we make our way through, you can see there's a clickable table of contents, so we can just, pick whatever. Let's say we want to go and look at netconf and Python stuff just to pick something. Now, this page kind of summarizes the capabilities of the book, or at least some of them, where I can insert links in the text. So there you see the words Dimitri, a friend of mine who helped me with some of this code, so I'm giving him a shout out and a link to his Twitter page. You can see I've got nice syntax highlighting in a monospace font to show code snippets. That works really well. And as we move through the book, we're not going to go through too much of it, but you can clearly see how this works. There's also images in the book as well. So here's just an example of just a picture, and I'm talking about SDN here. I can easily insert pictures with figure numbers, and all that gets automatically sorted. So how did I do this in a code project? Let me take you through the high-level components that make up the solution overall. First, we have the developers who work on the product, for example, me, other people who submit issues against the project, and maybe in the future even pull requests to add content. Now, in my case, I did my development on a MacBook. It doesn't really matter how you do the development, but I used my Apple machine to do development, and the language used was LaTeX. Now, this is kind of the replacement for Microsoft Word, even though it's pretty old and it can be hard to use. It's very popular in the academic world, but I think it makes sense to tie it in to a more modern continuous integration, continuous delivery process, because I think maintaining books this way, there's a real advantage to it. I chose to use Git for version control here. I think version control is important for any project where you're developing new content. For example, whether it's code or documentation, I think this is kind of a no-brainer. And because this is an open source project and I'm not really trying to protect any of the information, in fact, I want it to be public, I chose to use a public GitHub repository as my Git remote, basically. So all my code is accessible there. Now, in terms of the CI/CD pipeline, I decided to use Travis, which is a very popular CI/CD as a service, basically, that ties in really nicely to GitHub, and that's what I chose to use for this. Now, there are 4 high-level steps in my pipeline, and you're going to see a couple minor steps as we look through the files, but I'm going to break it into 4 major categories. The first thing we have to do is install the packages that we need in order for this project to work. So generally this is LaTeX and the supporting packages that are used inside of the LaTeX environment. Next, I use a linter known as check_tex, and what that does is it basically looks through all of my LaTeX files and tells me if there's any syntax problems or any other styling issues that I should know about. This is a good first step to ensuring that my code is good quality. Then I use the PDF LaTeX compiler, the shell command. I want to run a draft of my whole document, which doesn't render images, and there's a few other shortcuts it takes, just to make sure that before I run the full compilation that the files are in good shape. Then finally, I compile the final document, I bring in all the images, I do all the syntax highlighting, and I develop this final PDF, which from the perspective of Travis is considered an artifact. Travis also has the ability to upload artifacts to AWS S3. That's basically a remote storage service that I also utilize. So I tell Travis, hey, when you're done and you've got this final PDF, I want you to automatically upload it into my AWS account. That's why you see the arrow back to the user, is so that people can download the file and enjoy it. So at this point, you've seen the final product up front. You've seen kind of the high-level process. Let's take a look at the code at a high level. Now I'm using the tree command here with a modifier because there's a lot of images in the book and there's also a legacy section, and I just don't want to print out all that extra stuff because it's hard to get a high-level view of the directory structure if I show the extra junk. Like most code projects, you generally want to break large projects into a number of different files in some kind of intelligent hierarchy. So this specific book, as you probably saw earlier, was written specifically for the CCIE and CCDE written exam, the new evolving technologies, and there are three major areas of that blueprint. The first is cloud, the next is network programmability, and the third is IoT. Now the network programmability isn't on the screen, it's at the bottom, but you can trust me that it's there. And then I further break down the sections into subsections, for example, cloud design and cloud infrastructure, and then the individual blueprint topics I put in their own tech file, and these are the individual source code files. Now, they all get assembled together through my file that I called main.tech. So let's take a look at that real quick. So if you've never seen LaTeX before, here's what it looks like. This is just me in the beginning importing packages that I need, for example, support for tables, support for captions, support for graphics, setting the margins, really basic stuff up front, the things you would generally point and click in your Microsoft Word environment. I don't want to go over the code in too much detail, but I do want to show you some coding concepts that actually apply in LaTeX. In programming, many of us are familiar with the concept of a function, which is reusable code that we can invoke over and over again to avoid repeating ourselves and typing the same kind of subroutine over and over again. In LaTeX, I'm using some new commands to create kind of a pair of functions, and these functions are used for adding images, either with captions or without captions. And you can see I try to add comments before each one to try to make it a little obvious how to use it. And we use these throughout the document to add images. So again, structure your project just like you would a code project, and it can be very easy to use. Let's take a quick look at some kind of real LaTeX, like some real meat of the document, just so you can get an idea of what the code looks like. So I opened up one of my files from my network programmability section, and I jumped down to a section where I can show you some of the syntax highlighting capabilities. So there's a package called minted, which is actually written in Python, even though we don't really care about that. When you encapsulate code in these minted blocks, it will get the appropriate syntax highlighting based on the type of language specified. So if you just specify text, it'll be just regular black monospace, maybe it's just shell output that really can't be easily identified as a coding language. But you can also see something like YAML, which is well formed. We can absolutely do syntax highlighting for that. And this makes it really nice and good looking in the book without a lot of effort. Just quickly jumping back to the top of the document, you can see I can add subsections and subsections. And again, the same kind of thing you can do in like Word with numbering and headings and paragraphs and all that. You can do a lot of that same stuff. Now you can see there are a few kind of code isms through the language with different patterns, as you'll see as you look at this code. But again, this isn't a course on LaTeX. I just want you to be aware of what it looks like at a high level. Okay, so you've seen all my code here. I could just stop here and I could just manually build my book and manually update my website every time I make a change, but that kind of goes against the whole spirit of trying to have an automated delivery. I mean, this book is on evolving technologies and it talks about these new concepts, so it seems fitting that the book itself should be maintained using the concepts that it preaches. To me, that just makes sense. Next, I want to jump into my make file. Now, this is just kind of a helper file that I use to execute tasks when it comes to my build process. So earlier we saw that there were a couple different stages in our CI/CD pipeline. That doesn't perfectly match what the make file has, but this makes it really easy to manage my code project. So let me show you that real quick. So the reason I like to use make files in this project, and you can see that all my targets are phony here, because all I'm trying to do is just simplify running some shell commands. So you can see I have a target that's called lint, and whenever I type make lint, it'll run those 4 shell commands. So I have a few echoes in there, which just give me some kind of nice banners that tell me when the linting has started and ended. I write the date to a log file, and then I run my linter, the check tech program, against my main file, and I copy the output both to the screen and to the log file. This just gives me a good way to see what's going on in my code and find any problems. Then I have a target named draft, and I'm not going to go over that massive command on line 25, but PDF LaTeX is a compiler that can take LaTeX and output a PDF, as you would probably guess. In this particular case, I'm running it in draft mode, and I specify my main file, which ultimately will compile the whole project because that main file includes all the other files at some point. I then have a target called pass2. Now what this does is it runs the same command twice. In LaTeX, sometimes you have to run the compiler multiple times because LaTeX was invented when memory was very scarce in the 70s and 80s. So they used kind of transient files between compilation runs to store auxiliary data. And if you're doing something like hyperlinks or a table of contents or a bibliography, you may need to run the compiler multiple times. So I can type make pass2 to have that happen without having to type these commands multiple times. The last two are pretty basic. I have another one called PDF. What this does is first it runs the pass2 target. So it runs the compiler twice. Then it uses the open command to open the PDF. This is very handy when you're doing local development, so you can just type make PDF, it'll run the compiler twice, and then open up the document on your screen using the default program for PDFs. And on Mac, it's the preview program. On Windows, it would probably be Adobe Reader or whatever. But this allows you to make a change, do make PDF, and boom, there's your file. And you can just take a quick look and see how well it works. This saves a lot of typing and a lot of clicking. Then I have this make clean at the end. This just basically does what you'd think. It cleans up some of the transient files, even though they're not included in my Git repository. Sometimes I like to keep those clean if I'm seeing some kind of weird bug. The last thing I want to point out is this default goal at the top. Again, this isn't a makefile class, but by having a default goal called all, what that'll do is it'll run the lint target followed by the PDF target if I type make all. The default goal means if I just type make by itself, it'll assume I want to run the all target. So as a local developer, if I just type make, it'll do the linting, it'll run the compiler twice, and it'll open the PDF up for me. So it's a very quick way to kick off this whole process. Next, I want to talk about the files that I use to install LaTeX. And this was probably the hardest part, is figuring out how to do this. This is a basic bash script, which does the tech install for me, and you can see that it's all just comments on the screen. I was just listing all the packages that are included in the Tech Live Basic package, and I just did that just for reference, so I knew what packages it came with. So I'm just going to skip past that real quick. Now I also put this towards the top as I have a list of TL packages. So that's the Tech Live package list. These are the extra packages that I need for my specific project that are not included in the Tech Live Basic. Now you might be wondering, well, why don't I just download all the packages? Well, because that's like 5 gigs and I don't want to have to make a push up to GitHub and then make poor Travis download 5 gigs of stuff every time I change a word. So I wanted to see what is the minimum I could get by with, and starting with the basic package and then including about 20 more packages, it's not a big deal and it runs pretty quickly. Now that's just a list. I'm going to expand that later, but I just want you to see if you ever need to add or remove a package, here's an easy way to do it. Just expand this array. The first real thing we do is we use a web download, basically wget, and we go to that specific website and download the newest version of Tech Live. This is just an installer, so it's not a big file. Next, we have to untar it, basically unzip it, pull out the files so we can run the installer. Then we have an install script that we run. It's a shell script, and notice we are passing in a profile. You can kind of think about this like a configuration file which says, I want you to run the installer, but I want you to use these specific parameters so we can answer the interactive questions automatically, like, should I do a basic install or a full install? What language do you want? What keyboard layout? The install is normally interactive, and this is the way that you make it non-interactive. And we're going to look at that file shortly. After that, we need to update our path so we can get access to commands like TL Manager, the Tech Live Package Manager. It's basically like pip, except for LaTeX. We also need access to PDF LaTeX, the compilation function, so that we can assemble all of our code later. These last two commands, I'm just making sure that TL Manager is installed. We need to make sure we have that. And also I am installing all those packages from above. So you remember that array from earlier, it had like 15 or 20 elements in it. We can install all those in one command to make sure that we have everything we need for our specific code project. Next, let's take a quick look at that profile. This is a file that's automatically generated by TechLive. During the interactive installer, you can ask it to print out a profile. So in my case, I would do a basic install, I would see what the profile was, and I would just copy it off. We're not going to go through the settings here, but I do want you to see at the top, we selected the basic scheme, and then there are just some other details about what to do. So a lot of these are interactive questions you would normally be asked at install that we want to override, so we pass this profile in basically to answer those questions in advance. So by this point, you might be wondering, how am I going to demonstrate this in any kind of interesting way? Well, what we're going to do now is we're going to go to the GitHub page and we're actually going to fix a few issues in real time. So this is the public GitHub for the project, and you can see I've got 13 total issues. Most of those are enhancements or new topics to add or things that I think should change. But you can see we've also got a few bugs. So I'm filtering on the bug label right now, and there are 2 bugs. Let's check out one of them real quick. So this particular bug was submitted by my friend Jacob Zartman, and looks like it's about a month old, and he says that in one of my particular files on a specific line, I should have a hyperlink. So the end of the sentence says be found here. I probably wanted the word here to be a hyperlink, and I just forgot to put it in. Now, for those who knew me in the past, I used to maintain this as a massive Microsoft Word document, and I spent most of Christmas break transforming my book and building this project, and naturally there's going to be some things that I missed. So somebody was kind enough to open this issue and let me know. So I've already checked out this link. That is actually the correct link, so we'll make that change in a little while. Let's check out the other bug real quick. Okay, so this issue looks pretty similar, and it's actually in the same document. So this one says NFVAS datasheet here, but again, the word here doesn't have a hyperlink associated with it, and there is the correct link that we should add. Okay, we're back at the terminal now, and rather than make you watch me type out those massive hyperlinks and deal with that, I'm just going to show you the changes that I made so you can see what it would look like. So I'm using the git diff command here, which is going to show the difference between my uncommitted changes that I recently made and my last commit. So in this particular case, you can see the file that I edited was the a1binfra/a1b3nfv file. So that is the correct file that was identified. You can see the red minus sign, which says I removed the text that said here, and I replaced it with a hyperlink reference, which has the proper link. And you can see the word here is still there at the end, except now it is going to be a hyperlink. And you can see that I've done that twice, one for each issue. Now at this point, you're probably thinking, well, how can we test it? How can we make sure it works? Remember, we looked at that make file, and I should be able to just type the word make, and magically, after a couple minutes, the PDF should pop up, and I should be able to navigate that document and then see if those links are working correctly. And you can see that it ran my linter. There were no problems. It says no warnings printed, so everything looks good there. This compilation may take a little while, so I'm going to fast forward the video until it is done, and then we can check out the document. All right, so the compilation is over. We've got a new document. You can see the date, so this is just freshly generated. Let's scroll down to our table of contents and pick out this specific area to see if those hyperlinks have been added. Okay, so it looks like section 1.8.1, so I'll click on that. Okay, here's the section on NFVIS. We can see under bullet number 1 at the end, it says datasheet here. That was the first bug we fixed. Then on bullet number 3, it says third-party VNFs can be found here. Now I'm just going to click on these links just to verify that they work. We're not going to get into the product details or anything, but let's just verify that our change is functional. All right, this fix looks good to me. I don't see any obvious issues here. The question now is, how do we publish this? Like, how do we get this out so everyone can take advantage of these new updates? Yeah, I get it. These are really minor changes and no one's life is going to be changed with these minor differences. This is the difference between writing a book and not touching it for 5 years versus being able to update it at any time automatically. Let's explore how that works. The way most CI/CD platforms work is that they're going to have a build specifications file. Some platforms call it the build spec. Others don't really have a name for it, but in this case, it's called .travis.yaml. So let's take a look at this file and I'll give you a high-level summary of how it works. You might remember earlier I mentioned one of our packages, specifically the one called Minted, relies on Python. So I'm going to use a Python-based environment because of that. The first stage in our pipeline is the install stage, and you can see there are 3 shell commands that we run. And when Travis sees code, that is to say when we push it up to GitHub and Travis clones it down, it's going to run these 3 commands. So first, it's going to run the text setup as root, effectively going through our shell script, which if you remember had our list of packages, it did a wget to pull down the TechLive install, and it passed in our profile, so that should handle the tech install. After that, it updates the path. The reason we need to do this is because inside of that shell script, the updating of the path won't affect the shell that is currently running this process, so we just need to do that again, not a big deal. And then last, we have a few Python packages to install. Now, I'm showing them on the screen in orange just for completeness. I didn't open this file because this isn't a Python talk, but we do need to install a few things in order for our syntax highlighting to work, so we quickly handle that. Next, I have a before script phase, which does 2 things. It'll run the make lint and the make draft process. If you remember from our make file, if we type make lint or make draft, it'll do those individual steps. Now in my test, I just typed make because it combined a lot of these steps together. But for Travis, I'm a little more granular because we're going to get a detailed log, and I don't have a problem making the machine work a little bit harder than I would normally work myself, especially when it comes to typing. The last step is make pass2. If you remember, what pass2 will do is it'll run the compiler twice, and you'll end up with your final PDF. It doesn't actually open the PDF because if you think about it, a very small Docker container in Travis is not going to have a graphical interface, and the open command isn't going to make sense for a PDF. So there's no point in trying to have Travis open a PDF to look at it. I'm just assuming that at this point, if the PDF compiled, the developer has hopefully done his or her job and has checked out the document to make sure it looks good, and we just want Travis to publish it. Now at the top, I've got these add-ons, and these add-ons are things that generally happen after the script is done, after the testing is finished, and specifically I have these artifacts. And this target path under the artifacts specifies where on my website do I want to upload the artifacts from this process. So if you think about it, the tech files are all the source code, but the PDF was one of my artifacts that came out of the compilation. It's not something I need to version control, but I ultimately do care about it and I want to upload it. Oftentimes developers in a more traditional software environment might use this for logs or any other things that get developed or generated by the application. So you might be wondering, well, I didn't specify the file name, I didn't specify any of my AWS information, where is all that stored? That's a great question, and it's inside of Travis. So let's look at that next. Okay, so here I am at the Travis site, and again, this is tied in with my GitHub. You can see that I've got a currently good build passing. You can see I ran it about a month ago. I haven't made updates since then. But I want to show you how was I able to configure Travis to know what file to get and know how to upload it to my AWS S3 bucket for storage. So specific to this repository, I made some custom settings. So let me show you those. Specifically, what I did is I defined some environment variables. Now, all of these variables are standardized within Travis, and if you just define them and you spell them correctly, Travis will know what to do. So for example, the bucket name is my website name. I enable debugging with artifacts debug 1, which gives us more details in the log. Now, in order to have programmatic access to AWS, you're going to have a key and a secret, basically a username and a password, and those are secrets that I don't feel like I need to show those to you, but you can just know that they're correct. You can get those from your cloud provider. the artifacts paths. So here I'm using a built-in variable called Travis build directory, and I'm saying look for the document that's called etech.pdf. If you haven't guessed, that's the name of the book. And that's what we want Travis to take and upload to the website. And my particular website is in US East 1. That's where the S3 bucket is hosted. So I want to make sure I specify that as well. This is how Travis knows what to do. Let's make our way back to the terminal so we can actually commit these changes, push them up to GitHub, and then view the results on Travis. Okay, so we saw the differences from Git. At this point, we just need to do basic Git operations to add the changes to our staging area, commit those changes to our local Git repository, and then push them up to the remote Git repository, which was on GitHub that we just saw. Okay, that was pretty easy. Now this is when the magic starts. If we jump back to Travis, what we're going to see is that Travis is going to create a new build environment, and it's going to take a few minutes to run, so we'll fast forward through that. But once it's done, we'll inspect the logs and we'll verify that the new book has been published without any manual action. So here we are back at Travis. A couple seconds later, you can see it's been running for about 30 seconds now. We can see our commit message about fixing some NFVIS issues. Again, this will run for a few minutes, so I'll fast forward through it and then we'll look at the log. And again, you can tell by the yellow color that it's actively testing. There's a little spinning figure 8 there that indicates action is occurring. And we're either going to get a green check mark or a red exclamation mark if it passes or fails respectively. So let's wait this out and check it out in a minute. All right, that wasn't too bad. It only took about a minute and a half. So a pretty quick process. And that included everything from installing TechLive to doing all the linting to doing the compilation and uploading the file all happened in less than a minute and a half. So as we make our way through this log, it's just going to look like shell commands. So it's not a scary thing. And I'm not going to unpack every line. You know, for example, you can see that it took 158 lines just to build the system. We don't really care about that. Let's just pay attention to the interesting stuff. The first thing Travis does is it does a git clone and pulls down our code from GitHub. This is true for any project, whether it's a book or code or whatever. Then we can see it starts running our install phase. Remember, we had 3 commands. We need to run our tech setup script as root. We need to update our path, and we need to install some Python packages. So we did all that. Then it continued on with our next phase, which was lint and draft. And you can see the phases on the right inside of those gray boxes in case you're not sure what phase a specific task was part of. Then we ran our make pass to, which was we have to run our compiler twice, which we did, and that worked fine too. And we've seen a lot of this output before when we ran it from the shell. So we don't have to dig too much into it. You can see from the tech setup, there's like almost 400 lines of output. There's no way I'm going to expand that here, but you can all go to this website. This is a public URL and you can dig through this log on your own, and I recommend that you do. Now at the end, we can see, okay, all the testing and the compilation is done. We need to upload some artifacts. We can see that the artifact specified is the etech.pdf document. It's uploading it to our njr_usmc.net bucket. The target path is /pub. This is important because this is where I keep all my publications on my website, whether they're books for sale or free books or white papers, they're all in the pubs folder. As you can see, there's a lot of debug output here. I'm not going to, read all of it, but towards the bottom, we can see the file was about 7 megs, so really not too big. And it shows us the download URL as well to get the file. Now, there's a couple of different ways to get it, but we can see this debug is useful because it shows everything that's going on in the background. Now, at the end of the process, we can see it exited with 0. So return code 0 in Linux Unix means success. So that's why we ended up with that green check mark. So everything looked like it worked okay. The only thing we have left to do is to make sure that the file actually works and maybe close out our issues on GitHub. So first, let's check the file and make sure that those new links are there and functional. Okay, so here's the publication section of my website. I'm using a different browser here, specifically Safari instead of Firefox, just to ensure that there's no cached book or old version lurking in the background. Sometimes I've seen that happen with browsers. So if I want to check this new book and make sure it was updated properly, I just click this link on the left that says Cisco CCIE CCDE Evolving Technologies book. And then it brings up this book. So right away, we notice the date is today. So this is great because the old date was about a month ago, which was the last time I made a change. So it's highly likely that our changes were published correctly. Let's go check those hyperlinks real quick and make sure. And if you remember, I think it was section 1.8.2 where we made those changes to NFEIS. Okay, so here it looks like we have those changes. So we have the two hyperlinks that say the word here. So I'm just going to use command click to open these up in new tabs, just so we don't lose too much attention. And let's just look at the titles. I'm going to be a little bit lazy here, but you can see the names of these tabs. So one of them says NFV Infrastructure Software. That probably makes sense considering what I'm talking about in that sentence. And then our next one says Enterprise NFV Open Ecosystem and Qualified Vendors. Okay, that makes sense because we're talking about third-party vendors in that third paragraph there. So everything looks like it worked out okay. The last thing we should do, because remember this is a code project, is we should go back to our GitHub and close out those issues and maybe put a little bit of comment in there. So let's do that next. So one thing I didn't do is in my commit message, I could have referenced these issues. I could have said, hey, I fixed number 18 and number 19. I just didn't know the issue numbers as I was typing that message. So we can always go back and fix that though. So I'm going to click on one of these and we're going to add that in. So at the bottom here, I'm just going to say that I fixed it and I'm going to specify the beginning of the SHA-1 commit ID, and then GitHub will turn that into a link for us. We can check out the preview if we want to make sure the link works too. Okay, so that link looks like it worked. So at this point, I'm going to click close and comment, and this issue will be all buttoned up. I'm going to quickly fix the other one without a whole lot of commentary because I think you understand what I'm doing at this point. Okay, at this point, we don't really see any more bugs. I'm just giving you all kind of a sneak peek of some of the new enhancements and other things I'm looking at doing here, but clearly our two bugs are gone. Let's wrap up by looking at our high-level diagram again, just so you have an idea of what we talked about in this video. Okay, just to recap, remember, we started as a developer, as that person in the middle, on a MacBook or whatever. We wrote some code in LaTeX, we made some changes, we used Git to version control it, we pushed those changes up to GitHub, and then Travis did a lot of heavy lifting for us. It handled the installation of all the LaTeX packages, including any supplementary Python packages that were needed. We ran a linter to make sure our code was good quality before trying to compile it. Then we built a draft to quickly ensure that the code at least had some functionality to it, maybe not bringing in all the images, but still a useful step. Finally, we built the final PDF ready for consumption and then uploaded it as an artifact into AWS. And I didn't talk a whole lot about the cloud side, but obviously it worked, is loading it into AWS, having it available on my public website, and then people can just download it and I don't have to go through a whole bunch of pain. I just do a git push and I walk away and the book is public. I hope you all enjoyed this video. This isn't just for technical stuff. You could be writing any kind of book, and I feel like this would still be useful, especially if you're trying to incrementally get it out there. Now, of course, there's companies like LeanPub and other publishers who understand and operate this way, and I think that's great, and I love doing business with them. This is a great side project if maybe you're publishing something and you want to kind of go through the flow on your own and play with it in a little bit different way. This can be a very good approach. Thanks, everyone, for your time. Hope you learned something today. Feel free to leave comments or reach out to me if you have any more questions. Thanks, everyone.